Good morning, Tahmina Khan is here in TKMaths is Fun. In today's video, we will see a question on permutation and combination, and it is a very interesting question, past paper question. It came in June 18. So let's see the formula just to refresh our memory. It will be given to you in MF 19, so you don't need to learn it by heart. But you need to understand one relation which will not be given, which is here. So if you look at this formula of combination and the formula for permutation, so the only difference is that in combination we divide it by r factorial because of the repeated cases. In combination, order is not important. I'm sure you know that thing. And in permutation, order is important. Right? So to make it equal, we say NPR is equals to r factorial times NCR. So let's see the question now. That was just to refresh your memory. So there are three parts of the question, and these type of questions are very popular. Mostly they are asked in recent papers, right? So part 1 is saying find the number of different ways that the 9 letters of the word happiness can be arranged. So there is no selection, all of the letters you have to arrange. So the best way is always write it down, which can give you at a glance the idea which letters are repeated, and you do not need to read them again and again from the word happiness in this case. Okay, so there are two S and two P's. So I have a habit of writing like this. It helps me to understand how many letters are repeated. Okay, so now total letters are 9. So in part 1, we use factorial for the rearrangement of all the letters, and the repeated cases are P's and S. So I will use 2 factorial divided by 2 factorial. So that is all. Use your calculator and you will get the answer, which is representing total number of different ways to rearrange 9 letters. Okay, so now part 2. Now in part 2 there is a condition. Again, the 9 letters of the word happiness are arranged in the random order. You have to find the probability that 3 vowels are not all next to each other. Now there are two very technical thing, I would say. If somebody is not reading the question properly, he would miss it. Number 1 is the word all. Usually in the questions it says, for example, the 3 vowels A, E, I are not next to each other. So the technique to handle those type of questions is different, which I have explained earlier in my videos, and you will see the link in the description. In this case it is saying not all next to each other. And very important thing, he is talking about the probability, not just the arrangement. And whenever we are talking about probability, the denominator have all the possibilities, right? Which is called sample space, all the possibilities you mention. So in this case, when you are arranging 9 letter, the total possibility is what? 90720. So in the denominator you will have 90720. But what will come in the numerator? In the numerator you have to talk about those arrangements in which A, E, I together are not all together. So what we will do in this case, we will find out the cases in which all three of them are together, and then minus them from the total cases. So what we will get? In which they are not together, all of them. Okay, I'm talking about all. So let's see when they are all together. 1, 2, let me change the color here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me put them together somewhere. Okay, it could be anywhere, so I'm just putting it here. So this block will actually act as one blank now, because it will always be together. So now how many blanks I have? 1, 2, 3, 4, 5, 6, 7. So it means 7 factorial, okay, divided by, again there are 2 P's and 2 S. 2 factorial into 2 factorial, multiply by 3 factorial. Do you know why these 3 factorial is here? it is because of these three letters within the block, they can move or change their places. So that's why this is 3 factorial. So the answer of this, let me use the calculator, is 7560. So what is this number representing? This number is representing in how many cases they are all together. But what question is saying? They are not all next to each other. So I have to minus this answer from the total possibility, which was what? 90720. That was the total number of possibilities, minus the cases when 3 of the letters A, E, I are together. So what did I get? 83160. So these are the ways in which these three letters are not all next to each other. So I have to find the probability, not just the arrangement. So now to find the probability, I will use, this is the favorable outcome divided by total number, right? So this will give you the probability. I hope you understood. If you don't, please write the comment, your concern in the comment, and I will explain it to you. Okay, so now the third part. Let's do it on the next page. Find the number of different sections of 4 letters from the 9 letters of the word happiness which contains no P's and either 1 or 2s. Now this is the case of condition. You have to select 4 letters. Okay, 1, 2, 3, 4. Now what is the condition? There is 0p, mean p you have to minus. Let me write the word happiness again here. Happiness. Okay, so now 0p with 1s, or mean plus, we will add the answer later, or 0p with 2s. So these are the two conditions I have to follow to find the number of ways I can select 4 letters. Okay, so now 0p is mean p's are out. So 1s is selected and here 2s are selected. Now s are also gone. So let's consider this case first. How many letters are left? 1, 2, 3, 4, 5. And how many I have to select? 3 in this case. So I will write 5C3. Because it is a selection, it doesn't matter order. So I will just write down the answer. 5C3 is 10. Now in this case, again 5 letters, 1, 2, 3, 4, 5. Out of 5 letters, I will select any 2 letters. How many ways are there? 10. So 10 plus 10, 20. So 20 are the different selections in which either there will be 1s or 2s with no p's. Okay. So thank you very much for watching this video. Please press like and subscribe button. And if you actually like it, then share it with your friends as well. Thank you. Take care. Allah Hafiz.